Hi everyone. Hopefully your preparation is going well. These are the questions we are going to try in today's episode. The questions are picked up from the first practice session of geometrical counting in mathematical courses. If you have tried these questions, then go ahead and watch the solutions and discussion related to it, which will be starting right away. And if you have not tried it, we'll recommend you to try it once before you watch the solutions. Before we start discussing the solution, let me take a moment to introduce some fascinating courses at Mathoratory. Simply visit our website and check the plethora of options we provide for CAT, GMAT, and other aptitude test preparation. We strongly believe in providing flexibility and convenience to students as per their requirements. You will have an option to either take a full course or learn exactly what you need to. For instance, if you plan to prepare one-to-one live with mentor, you can book sessions for only doubt clearing or even just for analyzing your mocks. Even for CAT preparation, if you don't need the one-to-one guidance, the mocks, the mock analysis, the workshops, or the GDPI, which are actually included in the comprehensive course, and you just want to train for specific topics of your choice, then simply select a capsule from these numerous options which are available to you. It will cover everything from basics to all variations and applications of the topic under study. Take a trial or book a demo with us and select the course which best suits your needs. Let's now continue with today's video and enjoy the solution and discussion related to it.
So there's a grid in which each row has 6 unit squares and each column has 7 unit squares, right? So how many squares are there in the entire grid? So we're looking for the number of squares. See, square is a rectangle, but there's an additional constraint to a rectangle being a square. And that is each of the side has to be equal. Right? So what I've done is I've just taken a few of the instances. So there will be a lot of these instances. We'll discover these in terms of dimensions. So let's start with the 1 cross 1 unit squares. If you look at a row, in this row, you have 6 of these, right? You have 6 of these squares in a row. And in each column, you have 1, 2, 3, 4, 5, 6, and 7. So you have 7 possibilities. So if you think about the 1 cross 1 unit squares, so there'll be 6 in each row and 7 in each column. So that will be the number of squares of 1 cross 1 unit. Now, if you consider 2 cross 2 unit in a row, see what is happening is you have one like this. This is the second one, right? This is also another square. This is also another square. So how many of these are we getting? See, because the spacing is 2 units now between the vertical lines, you should get one less square than you were getting in the previous scenario. So we're getting 5 squares in the row, and similarly in the column, we'll again get one less square because of that increase in the spacing between the horizontal lines. So you'll have one less in each row and one less in each column. So the number of squares of 2 cross 2 unit, these are the number of squares basically, of 2 cross 2 unit will be how many? 5 into 6. Now this is pretty obvious, right? What is going to happen next? So if I consider 3 cross 3 unit, again, because of the increase in spacing, there will be one less square in a row as well as one less square in a column. 1, 2, 3, 4, and 5. That's it. So every increase in dimension, you're going to have one less square in a row and one less square in a column, right? So somewhere down the line, this part will reduce to 1, and correspondingly this part will be 2, beyond which we cannot reduce any further. So if you add all of these possibilities, this is a type of series that we discussed. So 1 into 2 plus 2 into 3 up to 6 into 7. In these kind of summations, all you have to do is just write the last term, multiply the next number, and count how many values are here. So 3 values, so simply divide, right? So there are 112 squares. So in the previous question, we had that additional constraint. You need to have equal spacing of the vertical lines and the horizontal lines. But when we are counting rectangles, in this case, we are counting rectangles. We don't have that constraint. So all we have to do is choose 2 vertical lines and 2 horizontal lines. I've just chosen a couple of this here, just as an example. So you can see I've chosen 2 vertical lines and 2 horizontal lines. So whenever we do that, there will always be a rectangle formed in between, right? So you just need to select 2 vertical lines and 2 horizontal lines. That's it. So in this problem, you have how many vertical lines. That is something you have to count, because each row has 6 squares. So the number of vertical lines will be one more than that, isn't it? So there will be 7 vertical lines. And similarly, each column has 7 unit squares. So you should have 8 horizontal lines because of that. So you have 7 vertical lines, you need to choose 2 of them. And you have 8 horizontal lines, you need to choose 2 of them. You need to choose 2 vertical lines as well as 2 horizontal lines in order to form the rectangle. So these are corresponding cases, so simply multiply these two. So all you're getting is 21 times 28. 7C2 is 7 into 6 by 2, and 8C2 is 8 into 7 by 2. So 21 into 28. Now the last digit is obviously 8, and even if you multiply something like 20 cross 25, that itself is 500, right? So this number should be greater than 500. So answer is option B. Only one option which is more than 500 as well as having a last digit of 8. This one is an interesting question. So you have the same grid, and we are looking for how many pairs of unit squares can be selected from the grid which have exactly one corner in common. Now, I've drawn 2 arrangements here. If you look at the 2 squares in blue that are highlighted in blue, they are sharing a corner. And the 2 squares in green, they are also sharing a corner, isn't it? So there are these 2 arrangements here. Either it's in this shape, so something like this, or in this shape. Now, there are 2 ways to count this. One is that you figure out how many of these types you have and how many of these types you have, and then add the cases and you get the answer. That is fine. It's absolutely correct, logical. If you think about this, see this intersection that we are getting in this case, or the intersection that we are getting in this case, these types of intersections can never occur in the boundaries, right? So if you try to shift this, let's say, let's try this out once. If I try to get this intersection in the boundary, then one of the square will be outside the region, isn't it? It's not possible, either this, or even below or above. So the intersection points cannot be on the boundary of the square, right? That is not possible. So what about these intersection points? Where can these intersection points be? Anywhere inside the region, right? Any one of these could be these intersection points. See the example that I took. This is one of these intersection points. So these are all the intersections. I'm not drawing all of them, of course. Now think about it. How many of these intersection points do you have? Because there are 6 squares in a row, these intersections is in between 2 of these squares, right? So in a row, you will have 5 intersections. And similarly, in a column, you will have 6 of these intersection points, right? Because there are 7 squares in each column, right? So in the entire figure, you will have 5 into 6, that is 30 of these intersection points. Now understand, for each intersection, you will have 2 of these pairs of squares that will be that can be selected. So for each intersection, we are getting 2 squares, 2 pairs of squares. So how many pairs are possible? These many. So 5 into 6 into 2 simply. So the answer is 60. This is a very interesting problem. You can do it very quickly. You don't even have to draw the figure, because there are 6 unit squares in each row. This should produce 5 intersections, and there are 7 unit squares in each column. So that should produce 6 intersections. So that is this 5 and 6. And then for each intersection, you should be getting 2 of these, right? The 2 blue ones, or in this manner, the 2 green ones. So the answer is 60. Okay, the previous question we have already discussed about this blue arrangement and the green arrangement. So let's keep a note of that. Combination of these are a total of 60, right? So let's keep a note of that. Because in this question, what are we looking for? We're looking for how many pairs of unit squares can be selected from the grid which have at least one corner in common. So if it says at least one corner in common, even arrangements like these and arrangements like these can be selected now, because they are having 2 corners in common. See, none of the squares can, no pair of squares can have three corners in common or 4 corners in common. If they have 4 corners in common, they are the same square, right? So 1 corner in common are 60. And now we are looking for 2 corners in common. So if there are 2 corners in common, now you can think about in this way, there are only 2 types of rectangles which will satisfy that this idea. One is a 1 cross 2 rectangle, and another is a 2 cross 1 rectangle, isn't it? Let's consider this 1 cross 2 unit once. Say it's a 1 cross 2 unit. So this is going to happen, right? So either this 1 or this 2 or this 3, 4 and 5, right? In this wise or in the horizontal manner, these types will be 5 of these in each row. Similarly, in each column, now in each column, the spacing is only 1 unit. So how many can we have? So 1, 2, 3, 4, 5, 6, and 7. So you have 5 for each row and 7 for each column. So these types will be 5 into 7 in number. So that is 35 of these types. Similarly, if we try to count the ones which are 2 cross 1 unit. So 2 cross 1 unit is between the vertical lines you have 1 unit spacing. So how many of these can you find in each row? In each row you will have 6 of these, but in each column, now the column is 2 unit in space. So you have 1, 2, 3, 4, 5 and 6. That's it, right? So you have 6 times 6, that is 36 of these types. So the number of squares which have 2 corners in common will be 35 plus 36 or 71 in total. So you have 60 of the ones which have 1 corner in common, 60 pairs of squares, and 71 pairs of squares which have 2 corners in common. So the total will be how much? 131. So the answer is 131.
Hopefully, you liked the solutions we provided for these questions. And if you did like it, do not forget to like the video and share, subscribe, and comment. And if you plan to prepare with us in a structured manner, then do check the courses in our website. In the CAT comprehensive course, you will not only be prepared for each topic for CAT, XAT, NMAT, SNAP, IFT, but you will also have a one-to-one guidance and doubt clearing throughout your preparation. The workshops, mocks, and sectional tests will prepare you for strategy and decision making in the tests. The GDPI WAT preparation is also included in the course, making it a one-stop preparation hub for CAT and other management entrance tests of India. Take a trial of this course and check the way we have trained before you make the actual purchase. For both CAT as well as GMAT, we also offer the option to attend the classes live and one-to-one with mentor. Depending on whether you are preparing for CAT or GMAT, check the relevant course among these two. You will have the option to take the full course or customize the sessions as per your requirement. For instance, you may purchase the hours for just doubt clearing or mock analysis or any specific topic. Simply book a demo with us and have an experience of our one-to-one sessions. We also have mini courses, which we call the capsules, customized for you to select specific areas and train yourself. For each specialized area of training, you will be trained everything from basics to all types of applications and variations of that particular topic. If you are looking to strengthen your understanding of specific areas of any section which are tested in CAT, GMAT, or any other aptitude tests, then this will be the perfect course for you. Each capsule will have video lessons as well as practice sets covering all areas of that topic with video explanation of each question that are discussed in the practice sets. Every course at Mathoratory is designed to provide flexibility and complete support as per students' requirement. We will always be there to guide you and help you prepare as best as we can. Simply visit our website and check the relevant course. Book a demo with us or take a trial of the course and make the right choice as per your need. Thank you for joining in and have a pleasant preparation ahead.